So hi everyone. We have only 167.5 slides to go through, so let's jump into it. Today I'm going to talk about perfecting CI pipelines in Ember projects, hopefully faster, and for sure with more insights. So first of all, who am I? I'm Tomek Nieżurawski. I'm a staff engineer at Forest. I'm Polish, which you might guess from my accent or not. I have a blog, tomekdev.com. I wish to write more, but we suffer the same thing, lack of time. And kind of my motto is that I connect humans and machines. So I really love to work on interfaces, making them faster, with better UX, all that stuff. But it's not going to be about it today. Today is going to be more about DX, I would say. And first of all, a small recap. A year ago, I was talking about performance culture and new opportunities that actually Embroider gave us. And, what is the culture without some updates? I wanted to give you some update on that, very quick. Last year, I finished the presentation with a slide like that, where after 1,300 PRs merged, our common bundle was 200 kilobytes smaller. So we were doing improvements over time. And now a year passed. So where we are today, actually after shipping 1,500 PRs, our common bundle is 100 kilobytes smaller, slimmer. And as you can see on the on-demand chunk, thank you, is we shipped like around 1 megabyte of gzipped code, and we were iterating through interfaces a lot. So yeah, I think if you didn't see that presentation, it's on YouTube. And yeah, first of all, I would say if we are talking about CI and Ember projects, to be honest, I don't use Ember new that often. Maybe I used it a couple of times, so I don't know exactly what is out of the box. So I wanted to check if we have anything there. And apparently we do. A new project gives us a pre-configured GitHub file configuration with linting and tests. So it's already a good start and can be a great pointer for us how we can optimize things. Because first thing I notice here is that we are running linting and tests in parallel. So that's good. I remember it wasn't like that always. I'll skip to this slide. I think it's an improvement of the past because maybe this is like memory I made up, but I have a feeling like before we were running these tests and linting together, it was like JS hint and then AS lint, and you had to disable linting, and this is what I was always doing. And right now this checkbox doesn't do anything, so I guess it's a relic from the past. But this is already a good pointer. One thing that I'm not sure about is that we are giving like pre-configured GitHub, which in a way we are pointing a business, right? I actually prefer Circle CI a bit more, so the examples will be on Circle CI, but doesn't matter that much, I would say. So let's take a look at the optimizations that we already have in this file, because this is going to be a good pointer for us. First of all, we have install dependencies, and if you look closely, it's not npm I, but npm ci. I don't know if that command is faster or not, but it's for sure more strict for designed for CIs. So that's a good pointer, first good pointer that we can do something about it. The next pointer is when we install Node, I'm not sure if that's not the default, but we have it there, cache npm. So it suggests that some cache might be used. One thing I would change probably, but this is my thing, I use NVM, and I know there is ASDF in Volta for managing Node versions. So I would probably read it from a file to just keep it in the one place. And this is like gold. Maybe you will just earn money for your next ticket, for the Ember Fest. Because by default, GitHub has default value when it comes to timeout set as 360 minutes, which means 6 hours. So if anything goes wrong in these scripts and your job is going to get stuck, it's going to run for 6 hours and you will pay for 6 hours for GitHub for that. Fortunately, someone thought about it and put that timeout minutes into the config. So it's another good pointer. But, let's switch to a big project. I had to de-optimize a lot of stuff at Forest and de-optimize things. We are going to use Circle CI. But again, we have tests, we have linting. Actually, I was really lucky here because it should take around 36 minutes to run tests and linting. And we can see the test is taking quite a lot of time. And what we can do about it? First of all, I think we used Yarn for a long time. So I switched us back to have the same configuration. It's npm CI. And we run about 2,100 tests. I think it's 2,200 now, but it was something like that back then. So, and I am already cheating a bit because we don't use like very huge container, which is called xlarge on Circle CI, but we use large. And if I try to use the same container, large, to run the tests, they're failing. So actually, it's not working. I already had to pay more to just have tests passing. So yeah, there is a difference between these two containers. Basically, xlarge is twice as big. And actually, the RAM is here the problem. Probably we'll see it, I think, in the next slides. The application didn't want to build because it was using 9 gigabytes of RAM or something like that, so it failed. But okay, if we add deploy to that, this is like a better representation, 36 minutes. At Forest, we deploy at the same time when you are on a PR, we deploy to production, to development. This is a different topic with some revision keys, so you can test it everywhere. And we do it in parallel, because no matter if tests are flaky or not, you can already test something manually. But of course, on main or master, when you really ship your feature, we wait for these things to pass, of course. So that adds a little bit. 4 minutes for the deploy, 40 minutes we are there, right? Great stuff. But if you add it to, let's say you have a hotfix to ship, so 36 minutes on a PR, everything went well. 40 minutes to ship it, that's 1 hour and 16 minutes to ship a hotfix. And of course, I guess no one of you is in that situation because someone would scream already. But I did this slide for my managers to justify my work. If I wouldn't do anything, we were in that state, So it's like that. So trust me. And don't judge. But okay, what we can do. Fortunately, there is an add-on that most of you probably know. By the way, the idea of this presentation is that you will find your situation somewhere there, There are some things that I still think about and will do later, you will see. Yeah, some of you will learn that magic command that will help you straight away after this conference. But some of you can just learn about way of thinking, I think. and I promise it's not vodka. Okay, so Ember exam, probably everyone knows it, but if not, let's go into it. But first, let's check what are our resources. I guess this is the part I was thinking that is failing. Like we used a container with 16 gigabytes of RAM, and it went over 60, so probably more than 8 gigabytes. That's why the large container failed. And we can also see, but later it's like, it's okay. But CPU, it's a lazy thing, I would say. Look, maybe, I don't know, 10, 15% average. We have a spike to 100%, but in general, this is a lazy machine, I would say. It does something, but yeah. So first, let's spin more browsers. We use our lovely Ember exam, split into 3, and run into parallel. So now is the question, why 3? 3 is the number of the browsers. This is because I would like to go back to the large container I was using. And I don't know if it's in the documentation or not, but kind of from my experience, it looks like you can specify that large container has 4 virtual CPUs. And kind of, I think, you have to leave for the orchestration of everything. And 3 you can use for the browsers. I'm not OS expert, but from my experience, if I try to use all the cores for all the browsers, it fails like half of the time. So splitting into browsers is effective. We can see now that the CPU is used more. With RAM, it's similar. And this is like a very beautiful optimization. Now the machine is more busy, but we are not paying for that. We pay for minutes. So we actually saved some money, and we are faster, 50% faster, because it takes 17 minutes and something seconds. So splitting into browser is very effective. One command, we are done, right? And we didn't spend a penny yet. Actually, we saved some money. But the load is not optimal. If you run a very similar command in your terminal and you use -- server, it's going to spin 3 browsers. And you can see 600 tests, 800, 700. So it's not optimal. Why is this happening, right? So doesn't feel right. And this is happening because splitting happens on the test files. And probably in your code base, you know that some of your test files let's say with acceptance tests, which are, of course, the longest one to run, you might have a test that goes through many cases, and in general, this file is going to take long. And you can have a test that is testing, 404 page. You go to the random URL, you check it, nothing more to test in this file. So you can feel that there is probably some imbalance there. And we can balance the load. The API is slightly surprising to me, but yeah, this is how it is. To be honest, I was expecting that I will just add a -- load balance to the command that I had before, but it's slightly different. But still, load balance, parallel free browsers sounds good. So at the runtime of the tests, we are going to move them to different browsers, right? So balancing happens in a fly. Now when we do the same experiment, you can see that we run only 1 test. 30 of 1 looks a bit odd, but the browsers have only 1 test to run. And let's say something inside is moving what test should go next. And that balancing is, again, very, very efficient. We are 59% faster than the beginning and 18% faster than the previous step. Again, we didn't spend a penny on that. So we are definitely doing something good here with simple commands. But there is time to spend some money. And we will buy more containers, but smaller. So parallelization, of course, we will have more containers to run the tests, but we'll go from X large to large. I will show you why. But yeah, we need to spend some money. I will use 6 containers. Why not? Let's say I have money for that. And there is like a command you have to adjust. This time you have to adjust it on your CI file because it has to know what is the number of containers and what is the container I'm running in. So this is like a magic command here. And yeah, I guess I don't have to explain parallelization here too much, but you can imagine it would be nicer to have multiple coffee machines than one. That could speed up the process of serving coffee. I don't know why I came up with that example, but you know. And what is going to happen is army of the browsers is going to run tests for us. So in this case, 6 containers, 3 browsers. So we have 18 browsers doing the job for us. And well, we are very well under 10 minutes. And I don't know, this is like a magic number. I don't have any data about it. I just like 10 minutes. So I think that it's good if your team can test things in under 10 minutes. I know, somehow cool. If you add that 4 minutes of deploy later, 15 minutes and you are done, which is good. So we are now 80% faster, 50% faster than the previous step. Yes, we had to spend a little bit more money, but yeah, this is why we are moving away from very large containers smaller ones, because now we are really squeezing the lemons. They are not longer that lazy, I would say. A lot of spikes in the containers to 100% of CPU. And with RAM as well, 75% maybe. That's the spike. Maybe there are some memory leaks. Who knows? I mean, I know, but I won't tell you. But the thing is that we are okay with 8 gigabytes of RAM, and the machine is busy. So you can say, okay, you spend money, you have better results, right? Money solves a lot of problems. Yeah, maybe. But I did an experiment for you that I switched back to that X large, and in parallel, I have 8 CPUs there, so I'm going to use 7 browsers. That means that I'm going to run my tests in 42 browsers at the same time, not 18 anymore. And let's see what is the difference. The difference is we are 1 minute and 30 seconds faster, 20% faster than the previous step. Now is the question if we really want to pay quite a lot more for that. I think we can look for optimizations somewhere else. And what I'm also trying to convince you here is that, yeah, money solves all the problems, but kind of to some extent, you want to really squeeze that containers and take all the power they have. So we are not going to do that. We can see again, RAM usage, probably garbage collector was lazy as hell, didn't do anything, and CPU also spikes, but So let's again maybe focus on saving some money. So when we look at the details of the containers that are running tests, a huge chunk of that is installing dependencies. Of course, we have to install them, but it's, I don't know, 50% of time, depend on the container, 50% of time, so that's not cool. And I'm not sure about GitHub, but on CircleCI you also have to pay for the transfer. I guess this is internal transfer in their infrastructure. They have mirrors of packages, all that stuff, but you still have to pay for that transfer. So maybe we don't want to transfer that much. They charge us for that as well. So we'll introduce something like a checkout code step. I think many CIs, many pipelines in the companies, it's like checkout, tests, deploy. So let's do the same. And what we can notice here, we are even using even smaller container. It still takes 2 minutes to install dependencies. But of course, now we have to save some cache. That's additional time. And the whole thing is 3 minutes, 30 seconds. So things are slower. We are still under 10 minutes, which satisfies me a lot and make my life better. But yeah, it's slower, right? We can also look at the test for, do I have a slide? Yeah. Things are actually faster on the tests, but because we have an extra step, we got step back. We are 75% faster, not 80 anymore, 20% slower than the previous step. But we are saving money. And when we look into details, we can see that restoring cache is much faster than installing dependencies. So, if installing dependencies is slow, can we make it faster? And yes, we can. So let's switch to PNPM. When it comes to Yarn versus NPM, I always felt like, okay, Yarn is new, right? It doesn't have to go for all the edge cases, corner cases. So probably it's new, like every new framework. Yeah? They're always faster. Where with PNPM, I think this is really like a switch in paradigm, using the symlinks, saving disk space. So let's see if that's the thing. One thing on Circle that we unfortunately have to do right now, when you use the image for testing in the browser, you have NPM, of course, installed, and Yarn installed as well, but not PNPM. So you have to add extra a few seconds to install your package manager. And the change here is slight from npm run to PNPM, and you don't have to use that dash thing. So again, a small change. For your projects, what you can find when switching is that you will find out that probably you didn't specify all the dependencies in package.json. They were working because of the resolution in NPM. But in PNPM, you have to be very strict about it, what you use. But other than that, it wasn't difficult to switch. And we have another success. Now our checkout code doesn't take 3 minutes 42 seconds, but 1 minute 7 seconds. So using PNPM, at least for our project, because I found a blog post saying that, all these benchmarks are like, depending on the project, sometimes Yarn is the fastest, sometimes NPM, sometimes PNPM. I think PNPM is always the fastest, but someone was trying to prove that, it depends on the project. So maybe for our project it's the fastest. I think you should try it. And what we can see also here, that linting took longer, but this is like a variance, I don't know why, but in general you can expect that the next steps will be faster as well, because the cache is smaller now, cache that you use, because of the symlinks, all that stuff. So again, 84% faster, 35% faster than the previous step. So now let's switch the topic a little bit to the insights. That's a small break. And I think we can feed the CI with test results. So first thing you want to do, probably you would like to still keep the default reporter for in TestM, which is tab, but you can switch on a CI to XUnit and save it to the file, to reporters, or whatever you want. But this is some XML. And now when we run tests, at least on Circle CI, this is why I like it a bit more than GitHub, you just add extra step and you say where your reports are, where all the XMLs are, and it's going to read it from there. One thing you want to do is, I think we didn't ship it with Ember exam yet, it's definitely on the master or main branch, preserve test name. This is important because when you run things in parallel, it's always like partition 1, browser 3, and the name of your test. Now you want to keep all the names of the tests the same, so your CI will see them properly. And these are the details. So I don't know if that's good or not, but we have a few flaky tests in 100 runs. On average, we were back then running that many tests. And this is all read from the XML files. And that's going to give us some new opportunities in the future. And we can see that the slowest test takes 24 seconds. It's not like this test is super slow. I would say locally it takes like, I don't know, 3 seconds to run it or something like that. But because we are squeezing these containers as much as we can, sometimes tests may run slower. So we can then examine flaky tests. I remember this flaky test is using math random inside, so probably that's because of that. And we also have the slowest test. We can examine it if anything weird is happening there. What could also happen maybe is that we are waiting for some animations that are long. And this is, of course, questionable, like a controversial topic. Should you cut off your animations in the tests, make them duration 0 or not? Different school of thoughts. Here, I think you could probably use something, still have animations, for example, but make them shorter. And again, thanks to these XML files that we generate, we can see that this test is flaky. And instead of going through all the details, the output of each container, which is like, you have to, I think, look for not OK or something like that and find that test. Here, because Circle is able to parse that XMLs and find, it gives us a nice interface that one test of almost 2,200 tests was failing. And as you can see, we don't have that name here. We can see the real name. And he also got a badge called flaky. So it's a good indicator. I think this one was actually around Ember table, where obviously we didn't read the documentation, because who reads that? And there was a note what to do to avoid flaky tests, all that stuff. So I think this is covered. And we can also gather test coverage. And it's, again, not that hard. We install Ember CLI coverage, which uses Istanbul under the hood. There are a couple of things you have to do. Of course, go to the README, because there is a different config, I think, for embroider and not embroider. I forgot to ask you about it. In one of the slides that I was talking about the last year presentation, I wanted to ask you, how many of you is using embroider these days? Oh, don't be shy. Okay. Ed is using embroider. That's good. Okay, I was expecting half, but I think we have like 10% or something like that. So we have some work to do. So okay, forget this config. It's for embroider. Go to the documentation. And of course, what you are going to later do with coverage is kind of your job. We use a third-party service, CodeCov from Sentry. And yeah, all we have to do is coverage true. By the way, Istanbul is generating HTML, like a little page that you can examine all your tests and see what is the coverage. So you can maybe also put that test results, that test coverage on S3 or something like that. I like to use a different service for that because it's going to give us historical data. And how it may look like, this is just an example from that service. So for Forest, our coverage was like 82 at the beginning, 82 something. Now the trend was upward, like we gained 1%, which is actually very hard to get more percentage because it is actually quite well covered. But yeah, this is like a good indicator. I would say, this is just my opinion, if you land between 50%, 70% of code coverage, definitely focus on tests more. If you are close to 80 or 80 something, I think you are doing a good job. 90%, in my opinion, is perfect. Unless, of course, you are a library, you are working on library probably, then 100% would be nice. But if you have a business project, 100% of test coverage probably is a sign that you are focusing on the wrong thing, right? You're not delivering value for your customers. But something like this, I consider healthy. So if you land there, I think it's okay. And that also gives us these little reports. This is commit of mine. I wouldn't put anyone there. So I was working on a feature behind the feature flag, and I didn't have the full functionality, so I didn't test everything yet. And that was moving the coverage of the whole project down by 0.07% because my patch coverage, so pull request coverage, was under 60%. Say, right? I will pay it back, I promise. It's recorded now. So yeah, the other day, let's say by doing some stuff, okay, and I was in some place, I added extra tests. So it's all about this, I would say. Just having a visibility. And it's, as you can see, it's not that hard to actually set up this. And to be honest, I wouldn't add any, because it's also possible, but I wouldn't add anything like you decreased code coverage, go out. Your PR isn't going to pass. We are not going to merge that. Because the situation may vary, of course. Same as Drew said about flaky tests. Sometimes it's better just to skip it and go back to it later. You have to be flexible. Otherwise, competitors that are more flexible than you will ship the value. So I wouldn't do it, but it's possible. And this is like end of the insights break. So now we know more about our tests. And can we run tests even faster? So we can still squeeze the lemons here. And if you look closely at these tests, these are different containers, 6 containers. There's some idle time. Some containers finish the tests earlier than others. So the others are now waiting for the slowest one. And kind of, didn't we already balance the tests, right? And this is yes and no. Balancing happens between browsers, but not between containers. And something that I mentioned earlier, the initial splitting happens on the test files level, not test cases. And this is not unusual, because first, testing frameworks first have to look at the files that are responsible for tests, right? So this happens everywhere. It's not only about our Ember ecosystem. Actually, Circle CI gives you a tool that can split the tests for you based on historical data. It doesn't work for us in Ember project. I've seen examples in Go, works probably fine, but still there's like, in the design, in test cases where you have, like I said, some test file can be huge, but it makes sense that it's bigger because maybe it shares the before each in some way. And some test files don't have that many test cases inside. So I think we are now getting into territory where there is a potential gain. You will see that little lab icon there, because this is the stuff I haven't done yet. In my perfect world, I thought I will submit the talk, I will deliver that, and will show you, but I'm not there yet. It looks from math that we should end around 3 minutes, 50 seconds, maybe 4 minutes, because there are different things in play as well. But in perfect world, we could finish somewhere like there. And to do it, we need a couple of things. We need to keep historical test execution times, and we already do. In this case, Circle CI keeps them for us. But we also need to change the way we split and run the tests. And this is my kind of, I'm not a vivid open sourcer. I don't have a lot of time. I'm rather like pet projects person. But yeah, if you have any idea, you can come and help me. The first thing I did, I actually took all the XML files, and this is like a raw execution time. It's not how long it takes for the container to run, but just tests. And then I realized that one of the containers had to run tests for 7 minutes, 9 seconds, right? And there is a question. And it's probably a little bit imbalanced, because there are 288 acceptance tests to run. Can we make it better? Actually, I thought that maybe algorithm for that is like crazy, you know? So I asked ChatGPT, and even ChatGPT knew answer for that. So it was really easy to sort these things and to properly balance them up front. So it looks like we can, still you can see, acceptance tests, integration, it's not equal. But we were able to find like a combination that is the fastest. All the containers should, of course they won't, but should end in about the same time. So here on the test execution, we have something like 30%, and the question is if it's doable. So maybe next year, if I'm again on the stage, I will give you an update on that. But it seems like it's doable. Our load balancer that we already have that splits things between browsers, maybe it could upfront divide all that stuff, know about the partition we are into, and give the right test based on historical data. So this is something I'm going to work on, and there is a potential gain. And there's also a question, also thought that, you know, I will do it and I will show you on the stage, but wasn't able. When we look at running tests, it takes a while, of course. When you get into the details, we can see that like we are building the application for 52 seconds, which is around 20% of this step. So if that would be like 5% or something, I would say, okay, but maybe if you can cut it in half, that would be already something, right? It would speed up things for us. So I'm looking for Vite support, as you probably as well. We are on the latest version of Ember, or one version behind, so I hope we are kind of ready for all the new stuff that will be there. I only used Vite with small projects, so it was building fast. And the promise is that it scales very well. And yeah, as I said, at the beginning, I thought, okay, I will just write that Vite integration, right? So I asked on Discord, and Preston, Null Vox Populi, said, wait for official support. So I was like, okay, I will wait for official support. So maybe next time I will give you an update on that. But these two things, run tests with historical data, and maybe building faster with Vite can give us even more improvements. So there's a small summary for you. We were able to run our CI 80% faster. And now we are really squeezing all these containers to run fast. We have more insights, flake tests, slow tests, test summary, code coverage, and that's not even all. I wanted to put more things, but time pressure, I would say. And there are two potential things that we can do. So we could balance the tests with historical data, which can maybe convert to 30% gain on test execution. And, and there's maybe another, at least for Forest, another 25 seconds to gain, which is, of course, a wild guess. I don't know if Vite is going to build things 50% faster. But there is some promise there, so maybe we'll be able to cut some time as well. And if you are looking, of course, into these things, and you are also interested, contact me. Maybe we can work on that together and get there together. And that's all I prepared for you today. Thanks, everyone. Until the next time.